So we're going to start with a basic long division problem with just numbers and not polynomials. It's going to seem, it's not because I don't actually care what the answer to 463 divided by 9 is, right? I know you know how to do that. I don't really want the answer. What I want us to go over is the process, that process, that division algorithm. It's the same process once we throw x's in. Okay, so I'll be referring back and forth, and I'll be like, what did we do when it was just numbers? Okay, now we're going to do that with our polynomial. But we first want to review a little bit of vocabulary. Because if you look at your notes, like when we get to the actual problems, it says, if you look at example 1, it says divide blah, 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 blah. And then it says write the result as quotient plus remainder over divisor. So let's review real quickly what those words mean. In this problem right here, 463 divided by 9, this number that's written first, that is your dividend. Okay, that's a dividend. And the number you're dividing by, I'd really like to call it the divider, but that's not the word, but it sounds like divider. It's called divisor. And when we go to do long division, remember we always set it up with the little like house thing. I don't remember what an elementary teacher would call that when they're introducing it, but I don't remember the actual name. But we set it up something like this. That first number goes under there. So the dividend would go under here. Whatever you're dividing by, the divisor goes on the outside. And we'd get some numbers up on top. That's your answer, right? You form your answer up there. That's what we call the quotient. The quotient is the answer you get when you do division. And if it doesn't go in evenly, what do you have left over? You have a remainder. So you would subtract off some stuff, and you'd get a remainder. And so your homework is going to ask you to take all those pieces and write your final answer like this. You write the quotient plus the remainder over the divisor. So when you see that on your homework, your notes, your quiz, your test, you'll know what that is telling you to do. So here's how all that goes down with 463 divided by 9. So 463 goes under the little house, divided by 9. Again, bear with me. It's not the answer that I'm looking for so much as we're reviewing the process of long division. So I'd start off by saying 9 goes into 4 how many times? None, right? So what do? I go to the next digits. So 9 goes into 46 how many times? 5, okay. 9 times what gets me as close to 46 as possible? So I'd write 5 here. What do I do with that 5? Multiply it by 9. Write that number here. And then what do I do with that 45? I subtract it off. Remembering that subtraction is the same as changing the sign, right? I'm going to subtract that off, change the sign. So that leaves me with, so then I add vertically. That leaves me 1. What do I do next? Bring down the 3, right? Bring down the next digit. And at this point right here, the process repeats, right? It's just the same thing all over again. 9 goes into 13 how many times? Once. So I do 1 times 9, which is 9. I bring it down here. Subtract it off means change the sign of the 9 to negative. And then that leaves me 4. So I'm going to write this in that form that your homework and your notes say. Quotient plus remainder over divisor. So that would look like this. The quotient is 51 plus the remainder over the divisor. Now, when we're talking about just numbers, we don't really leave that plus sign in there. We actually would write 51 4/9. The plus is just understood to be there. But this will be the form with our polynomials. We won't be smushing together the polynomials. Okay. So I want you to keep all those little tiny things in mind. Now we're going to throw x's in there, and exponents. Okay, so we talked about that process. So let's look at how that goes with this. So we've got divide x cubed minus 4x squared plus x plus 6 by x minus 1. Which of those things goes under the division bar, this long or this short thing? The long thing, right? Whatever's listed first. So I've got x cubed minus 4x squared plus x plus 6. And x minus 1 is the divisor, goes out front. Now here's the thing. When we just did this last problem, and I said 9 goes into 46 5 times, this is how that translates to the polynomial problem. What you're going to do here is you're going to look at the first terms of the divisor and the dividend. So this is my setup. And now we're going to look at this first, the leading term here, and the leading term here. And I'm going to ask you, okay, I'm not going to ask you how many times does 9 go into 46. I'm going to say, how many times does x go into x cubed? What do you think you would say? 2 times, right? X squared. Another way of thinking about it is x times what gives me x cubed? X squared, right? Your book writes that like this, and I'm going to write it here so you can see. But it's not how, it doesn't work well for my brain, but I think it might be good for you to see. The book says that what you're doing is you're taking a ratio of the leading terms, which means you're taking that x cubed, dividing it by x, and you're getting x squared. I will probably ask you x goes into x cubed how many times? Or I'll ask you x times what gives me x cubed, only because that works for my mind better. If this makes better sense for you, then you do that. So in the number problem, we figured that 9 goes into 46 5 times. I did not write that 5 above the 4, right? I wrote it above the 6 on purpose. It needed to go there. It's a placeholder. It's in a specific spot for a reason. Here's how that translates to polynomials. X goes into x cubed x squared times. I'm going to take that x squared and line it up above this x squared. Okay? So what you want to do is line up the degrees on top of each other as you work the entire problem. Okay. So in our number problem, we said, okay, 5 times 9 was 45. Here's what that looks like now. X squared times the divisor. By the way, how many things are in the divisor? 2. So when I say times the divisor, I mean x squared times everything in there. Okay, so it's like a mini distributive property in the middle of your problem. And then you're going to write that down here. So I've got x squared times x, which is x cubed. X squared times -1, which is negative x squared. So I've done, so I'm going to, so I did x squared times x minus 1. And in our number problem, that step was 9 times 5 is 45. What did I do with that 45 then? I subtracted it. And I have to subtract this thing right here. So subtract that. But let's talk about what that means to subtract something that has 2 parts to it. Okay. Subtracting this means I'm subtracting all of it. So that negative on the outside is going to really become like a tiny distributive property. It's going to change the sign of all those other terms. So this becomes plus negative plus. So notice now the x cubes cancel out. And then I have negative 4x squared, a positive x squared, negative 3x squared. So now I'm just adding vertically there. What do you think I'm going to do next? What do we do next in the number problem? We brought down the next digit. In this case, what's my next thing? That plus x right here. So I'm going to bring that down. And this is where everything just repeats now. Okay? So just repeat. We are going, now we're looking at this first term. x times what gives me negative 3x squared? Negative 3x, right? So negative 3x. If you want to think about it like your textbook teaches, like a ratio, you would take that negative 3x squared and divide it by that x. It's the same essential question, how many times does x go into negative 3x squared? So now we take that negative 3x times every piece in the divisor. So it's negative 3x times x, which is negative 3x squared. Negative 3x times negative 1 is positive 3x. I'm subtracting off both of those. What does that mean to their signs? Just flip the signs. But on which ones? Which ones? Both of them. I mean, I hear people talking about not. Is that what you're saying? Both of them? Yes, that's what I was hoping. Okay. So subtracting this means it changed to a positive. Subtracting this means it changes to a negative. So we're flipping the signs because we're subtracting. So negative 3x squared, positive 3x squared drop out. Positive x minus 3x is a negative 2x. Bring down the last term. Okay. Wash, rinse, repeat. I've got this first term here, x. This first term here, negative 2x. X times what would give me negative 2x? Negative 2. So that goes up here. And then that negative 2 gets multiplied by everything in the divisor there and brought down here. So I've got negative 2 times x is negative 2x. Negative 2 times the negative 1 is positive 2. And I have to do what with that? Flip the signs on which ones? Both of them, right? Because I'm subtracting off both of those things. So this becomes a positive, this becomes a negative. The two x's cancel, 6 and a negative 2 is 4. And that's a lot of beautiful work. It's even color-coded. But if this was me, I'd be circling myself for partial credit because I still have to do what? Right. Write it as a quotient plus remainder over divisor. So here's your final answer. X squared minus 3x minus 2 is your quotient plus the remainder over the divisor, which is x minus 1. Okay. So take a minute and try that problem that's on the bottom left. All right, so all of this gobbledygook goes under a division bar. And then the divisor goes on the outside. We're starting with our first terms, x and x cubed. X times what gives me x cubed? X squared. Where do I write that over? The 5x squared, right? So I'm going to write that here, 5x, so x squared. I'm going to take that and multiply it by everything here, and then write it down here. So that gives me x cubed plus 7x squared. And I do what with their signs? Flip them, both of them. So then I add vertically. So the x cubes cancel. 5 minus 7 is negative 2, x squared. What's my next step? Bring down the negative 17x, right? You bring down your next thing. And then that's where it starts to just repeat. So from here, you go back to the first terms, the leading terms. The first term in the divisor was x. The first term here is negative 2x squared. X times what would give me negative 2x squared? Negative 2x. So that goes here above this x. So then I take that negative 2x times x plus 7 gives me negative 2x squared minus 14x. I have to subtract those off, which means change both of their signs. So this becomes a plus plus. The x squareds cancel out. Negative 17, positive 14 is negative 3x. I bring down the next term. Negative 26, start all over, right? The first term here is x. The first term here is negative 3x. X times what gives me that? Negative 3. So that goes here. Take that negative 3 times the x plus 7. So it's negative 3x minus 21. Subtracting that off means change both of their signs. Plus plus. Negative 26 and positive 21. Negative 5. I've had a large number of people put positive 5. This is so funny. I don't know why. They just forgot that I was a negative there, but all this beautiful work, and then they are giving me positive 5 at the end. It's happened a lot today. I find it amusing. And so then the final answer is the quotient, x squared minus 2x minus 3, plus the remainder, which is negative 5, over the divisor. Plus negative is the same as minus, so you could rewrite this as, you could write this as well, either one. Okay. So who got that one right first thing? Okay, who didn't get right first thing, but now they got it? Okay, so it counts just as much, so it's almost the same. All right, we got one more problem to talk about. These problems right here, if you notice the title, those were for linear divisors. And that very last example problem, it's a nonlinear. Okay, it's a quadratic. And then there's this hint here in the parentheses. It says, use 0 as a placeholder for missing terms. That is not a requirement. I mean, I'm going to explain it to you here in just a second. You don't actually have to put a 0 in there as a placeholder. You could just skip space while you're working, which you'll understand what that means in a second. I'm going to do the 0 as a placeholder because it's a good support for students who are still a little iffy on the whole process. But if you're a ninja on the whole process already, you don't have to use the 0. But here's what that will look like. And here's what I mean. If you're looking at the dividend and looking at the x's, it doesn't skip any degrees. Okay, it goes like this. 4, 3, right? 4, 3, 2, 1, and then this has no x's. Okay? But the divisor does skip an x. Okay, it's skipping x to the 1. There isn't an x to the 1. So what I'm going to do instead is I'm going to put 0x in its place. And so that would start out looking like this. Instead of x squared minus 2, I'm going to put x squared plus 0x, because there aren't any, minus 2. And then underneath I have all of that craziness. X to the 4th. Oh my goodness. Okay. I'm going to do one cycle, or whatever you want to call it, and then I'll let you finish it on your own. We start with the first terms. X squared times what would give me x to the 4th? X squared. Where am I going to put that x squared? Here? 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 Above the 2x squared, right? So it goes in x squared times, note I'm skipping the whole first two terms, that's fine. And I'm going to put x squared right here. Okay, I'm going to take that x squared times everything in the divisor. So that will give me x to the 4th. And I'm not going to write 0 for the next term. What I'm going to write is I'm going to multiply the coefficients. 0 times 1 is 0. X cubed. Okay, so it's just a placeholder. You don't have to write that 0x cubed. You could just skip over to the next thing. You could just have nothing there, like just empty space. But I'll do it as a placeholder just for those students who it helps. And then x squared times that negative 2 is negative 2x squared. Okay. So I subtract that off by changing all of their signs, all three of them, just for consistency's sake. And then you add vertically. Okay? X to the 4th minus x to the 4th is nothing. 3x cubed and a 0x cubed is still 3x cubed. And then adding the x squared, you get 4x squared. And then you bring down the next term. Okay? And now you start all over. looking at the first term. So go ahead and try and finish that out on your paper. Take a few moments to do that. In case you're not using the 0x as a placeholder, your next step would look like this. It would look like 3x times x squared, which is 3x cubed. And then you'd be doing 3x times negative 2, which is negative 6x. You'd have to skip some space and line that up right here. Okay, if you're not using the 0x as a placeholder. But I am. So 3x times that 0x is 0x squared, which would go here. Then you change the signs. Flip, flip, flip. That goes away. This leaves you 4x squared plus 5x. Bring down your last term. Everything all over again. Oh my goodness, okay. X squared times what gives me 4x squared? Just 4, right? So that goes here. 4 times everything in the divisor, 4x squared, plus 0x minus 8. Okay, that's 4x squared, 0x minus 8. Change the signs. Change, change, change. Add, cancel, 5x plus 3. That's your remainder. That has 2 terms. That's not a problem. Okay, still just goes where the remainder goes. So we've got our quotient, x squared plus 3x plus 4. Let me tell you something. I do not want to see this. That is a multiplication problem, right? So what do I need to fix here? Plus, right there. Okay. So that is your final answer.